Good morning, everyone. Apologies for the delay in starting. My name is Joanne from Rockflow Dynamics Aberdeen team, and today I am hosting the session with my colleague Ari, who is based in our Kuala Lumpur office. So welcome. If you haven't joined an RFD webinar before, this is how it will work. All of the attendees today will have their microphone automatically muted. So if you have any questions, you can ask your questions on the control panel on the side of your screen, and we will answer as many of those as we can at the end. And if we don't have time to address your question live, we will follow up with you via email. This session is also being recorded, and you can find that on our YouTube channel later on Rockflow Dynamics Europe. And if you have any other questions or queries, feel free to contact us on asktnav@rfdbn.com. So this is the first webinar in our next series of 6. So today Ari will be talking about 2D geological mapping in T Navigator. And then, as you can see, over the next 3 weeks, we have a variety of sessions. In our webinars, we are showing you a wide range of demonstrations from each stage of the integrated workflow inside T Navigator. So if there's a functionality that you haven't seen before and you'd like more information about it, don't hesitate to get in touch with us for more details and trial licenses. So now I will hand you over to Ari to begin the presentation. Thank you, Ari.
Thank you very much, Joanne. So again, everyone, ladies and gentlemen, thanks for coming to this third series global webinar from Rockflow Dynamics. I will start with this topic, 2D geological mapping in T Navigator, for this third webinar series, and we will have the next 5 sessions in the next 3 weeks, right? So let me introduce myself very briefly. My name is Ari Krishna. I'm the senior geologist of Rockflow Dynamics, based here in Kuala Lumpur, Malaysia. I've been working in the industry for the last 15 years, and I've been working for Rockflow Dynamics for 2 years now. And for this particular topic, I will focus on the functionality of 2D geological mapping. So for the next 30-45 minutes, I will try to show the capability of T Navigator Geology Designer, especially in the 2D mapping, right? So I will show how T Navigator can generate structural map and 2D attributes maps, what are the available algorithms inside T Navigator, how to edit and visualize and doing QC. And I will also show some software demo at the second part of this presentation. And at the end of this webinar, we will have some question and answer session, which hopefully I can answer most of your questions, right? So for today's topic, 2D geological mapping, it might not sound as fancy or as high-tech as other topic that we have covered previously, but it doesn't mean that it's not important, right? 2D geological mapping is still an essential part of any GNG workflow, and I will show you the importance of doing both 2D geological mapping and also 3D static modeling. So before I go into detail in the software part, let's go back many years back in the early time of a geological map. Right? Traditionally, geologists have always translated their field data either based on outcrop observation or from well data, and then translate it into a geological map or a cross section, right? And of course, back in the days where we don't have the technology, all these maps are manually drawn on or sketched on a hard copy paper, right? And then later on, once the technology is found, then it's coming into a digital version. So the early map always is a hand sketch, right? It's drawn based on the observation from the field. So this image here is one of the earliest geological map from Southeast Asia. This area here is from Borneo or Kalimantan, and this is the first geological map that was drawn for this the whole entire Borneo and Kalimantan area for the geological map, and it was drawn manually, right, by hand sketch. So if you guys can guess on what year was actually this map produced, right? There is no technology back then, there's no computer and everything. So it's actually very early. It was late in the 19th century. The first geological map of Borneo or Kalimantan Island was produced in 1882. It was published by this gentleman here called Theodor Poswitz. He was actually a medical doctor that works for the Dutch Indies companies, but later on he will have interest in geoscience and in geology. And during his spare time, he works with his colleagues here, which are mainly geoscientists. And combining all of the reports from these three gentlemen, he managed to produce this geological map, even though he hasn't really visited many of the places. He was visited somewhere here, down here. He was based somewhere here, but then based on his friends' observation, he managed to compile a geological map from Borneo or Kalimantan. If you want to know more detail, this was actually written in a paper 3 years ago, December 2017, from Geological Society of Malaysia. So you can see geological map was there way before technology exists, right? And it was built by direct observation on the field, and then geologists tried to reconstruct the facies distribution, the geology rocks, and then tried to reconstruct it, how it looks like in a map view. And of course, not only map, geologists also create cross-section, right? So cross-section was already created long time ago manually, right? So whenever a geologist see an outcrop like this, right, then you can directly see how the geometry of the structure looks like, right? So if you're only based on the outcrop on the surface, maybe you wouldn't really have a clear idea that the folding or the syncline of this is so steep like this, right? But having a cliff where you can see the outcrop like this, then geologists have a better understanding of how to reconstruct this kind of geometry, right? So in addition to the 2D map, geologists always created cross-section based on the map. It can be either based on the dip on strike or on direct observation on a cliff like this. And combining map view and cross-section enables geologists to have a 3D space understanding, right, of the geometry of the structure. And later on, once technology comes, then everything can be digitized and can be drawn in a software and then can be visualized much better, right? It started with still 2D approach, and then later on, a 3D visualization comes in. And back in the late 90s, early 2000, 3D geological modeling approach has become more well known. So people also try to build not only the map in 2D, but also build it in 3D and try to populate the facies distribution in a 3D manner. So that's where it comes from. So you can see the importance of combining 2D and 3D, right? But let me have a different kind of approach here. Maybe this is more for my engineering friends. Which can relate more if I do this kind of approach. So imagine buying a property, right? A landed house or condominium, let's say. Normally what you will see from the sales or the developer, you will see the end of the product, the 3D model. Right? So let me take an example of the famous Petronas Twin Tower here, Malaysian National Oil Company office, right? So this design was actually win an award back in 1996, and based on this, the Petronas Twin Tower was built, right? And of course, this was the end product. But again, the architect doesn't come up just with this. Before they build this entire 3D model, they have to come up with certain detail, more kind of analysis for each section, for each floor, right? And it also helps the buyer or the government at that time to understand how it will looks like, how the entire layout within the building itself. So this where 2D maps comes in handy, or cross-section. This is the cross-section for the Twin Tower. And these are all the, let's say, the map, the 2D map of each individual floor and level. So you can see, right, this 3D model wasn't built entirely just by using a 3D. You build it slowly by having 2D map for each individual floor and then combine it later into 3D. And it also helps other people to understand it better, right? If you buy a house, firstly you see the 3D model, but then you want to see the detail, how big the size of the room, how the layout of the room, where the kitchen is and everything. That you can only understand by using a 2D map or 2D display. So it's very similar with subsurface geometry. Geologists need to understand the geometry of the rocks, and by combining 2D and 3D kind of approach, display and model, it will help them better to understand the subsurface of the reservoir. So now let's go to the next stage, which is the 2D geological mapping in tNavigator. Now, if you're already familiar with tNavigator comes as a simulation software first, and then we expand more to the GNG domain now, right? So we have expanded into 3D static modeling, 2D mapping, and also geophysics. So in this particular webinar, I would focus on the 2D geological mapping, which basically comprise of two main things, right? The structural map and the attributes map. So in this demo, I will show you how to do it and how to QC and visualize it using tNavigator. Firstly, with the structural map, again, you can use any kind of input data. If you have your well tops, your markers, you can use that to build a depth structure map, right? If you have an existing seismic horizon interpretation, you can use that as well, whether you want to build it in time domain or depth domain, right? Or let's say you already have an existing depth structure map from other applications. You can do that as well. You can use that and regrid the structural map. And if you have data points, that can be used as well, or polygons. And the combination of multiple data, you can use that as well, and then build a new structure map, a depth structure map in tNavigator. And of course, even though this is a 2D structural map, again, you can always display it in a classical 2D map view like this, or in a 3D space, 3D window, so you can have a better understanding, right, of the geometry of your reservoir. Or you can also have a cross-section window like this, right, so you can have a different kind of perspective from the geometry of your reservoir. So these are all can be done using tNavigator Geology Designer, and all the visualization are very interactive. You can connect each display and then maneuver it interactively. So the second part is how to create 2D attributes map. Typically, geologists like to create this, right, because there are some certain information that are below seismic resolution, right? So for instance, your sand thickness, right? So your sand thickness distribution, your isopac, isocore maps, your facies thickness map, or maybe your zonation map thickness, right? Or you want to create your average porosity map. These are all can be done, of course, in tNavigator. And what you need to do is create a well attributes, right? And then interpolate it using different algorithms. And then, of course, you can always use it in 3D window like this, combine it with your depth structure, or overlay it in a classical 2D map view like this, where you can see the depth structure contour overlying with the color of your attributes map. So these are all possible and can be done within tNavigator. Right, so this particular site will show you the algorithm interpolation that are available for 2D mapping now inside tNavigator. It started, I still remember, I think last year we only have about 3 or 4 algorithms available that is common to 2D structural mapping, but now we have expanded all the way until 8 list of interpolation here. And it's not only deterministic approach, but you also have a stochastic approach. Right? If you watch our previous webinar, my colleague Ivan from Jakarta have already presented the benefits of using Amazonas algorithm, right? So if you missed that, you can check it on our YouTube page where you can still see all the webinar, right? So in this case, this is just a quick snapshot of the different algorithm, right? The inverse distance weighting, the least square, and then conversion interpolation. So all these are available from the Geology Designer module, and you can just create it very simply in T Navigator. Okay, so now let's go to the software demo part. My software demo part will consist of 4 parts. So let me start with the first one, which is the creating structural map from well data or well tops. So this particular project, I'm using the same project as my previous webinar, where I show some machine learning capability that is available in T Navigator. But for this particular topic, I will focus on the depth structural map generation. Right? I will still use the same approach because I have about 500 swells here, and I want to interpret my well correlation very quickly. So based on my 3 seed points here, and based on the same gamma ray data that exists to all the wells here, once I normalize it so it have the same data range, I can use that, and based on the original interpretation, initial interpretation, I can populate to the entire well, right, that have the same gamma ray data. So you can see here within seconds, I can already generate my markers for the entire, I think 400 to 500 wells here. So it's very quick. And then what you can do next is, of course, then you can start generate your depth structure, right, based on your well markers load. So let's create the depth structure. Of course, you have several choices for algorithm interpolation that you want to use. For this particular example, I will show you 3 main common algorithms that typically people use for creating depth structure. And I just use it in the workflow, so I have to click it one by one. I can just do it in one go. So in an instant, I can already have my 3 different depth structure. And again, of course, to be able to visualize it better and understand better, you display it in a 2D classical view like this. And you can see here the middle here is the most smooth one, my least square interpolation. And this is my inverse distance weighting, where you have more of a bullseye kind of a result, and a convergent interpolation where it kind of honor the density of where your data is located the most, right? So let's say I want to go forward with my convergent interpolation, so I use this, but I still want to edit some part, because normally or generally we don't really get satisfied with one run, and maybe there will be other data that coming in, new well data coming in, or other data. So you want to have the ability to still edit your gridded surface. So you can do that very easily in T Navigator, right? It's always advised to edit it from a 2D window, like here, but you also want to have your 3D display next to it, just to have a better understanding of how the effect of your editing is. So for instance, I want to edit a certain contour here. I want to make the area slightly bigger. So you can see once I move this, the 3D also will be updated, right? And let's say I want to try to connect this area a little bit to this area here. You can also do that. And of course, the interpolation radius you can always adjust. So if you want to have a bigger one, then you will have a smoother kind of thing, right? You can always do that. Let's say I want to have it bigger, and then I can just type it down there and then kind of adjust the contour. And you don't have to worry, because in T Navigator, there is no limited number of undo, right? It always go back to the last time you save it, right? So as long as you haven't really saved or overwrite your project, it will always can go back to the very first creation of your 2D depth structure map here. And the other thing is you can also digitize it like in a polygon kind of way, but directly updating your structure here. So I can just digitize like that, right? You can see, and then I will update it, and it grid it automatically. And you can see also the update in the 3D window. And of course, these are can always be have an undo button, right? So let's go to the next demo. So once you already create a depth structure from one of your particular marker, but then of course you have maybe let's say you have 50 markers. So instead of doing it one by one, setting all the structure algorithm, the setting of the algorithm one by one for each marker, what you can do is you can just call the workflow, and then we have our newest functionality here called the for loop. So instead of typing it one by one, you can just select all the markers within the folder, and then you can set the name of the new horizon just following the marker's name. So it will add it the list, right, 1 to 50. So in this case, I'm making 50 new horizon based on my 50 markers, and then the naming as well will just follow the adding list. Right? So that functionality is available inside T Navigator. And if you wanted to have more advanced functionality, our workflow is embedded with Python. So if you have an existing script outside from Python, you can just import it in and then embed it here into the workflow of T Navigator. And you can see here, even though it's still running, the software doesn't freeze, right? You can still manipulate your 3D display. You can still do other things, which is really helpful if you have a lot of tasks to be done, right? So the software doesn't have to wait until you finish one task, and you don't need to open new license, right? Okay, so let's go to the next demo, which is creating a structural map from an existing horizon with false data, right? So let's say you have an existing horizon from your geophysicist, or from an existing 3D model, or from a mapping application, right? It's also doable. You can import that into T Navigator and then try to recreate the grid. So in this case, I have imported a surface, 2D map surface. And you can see here, even though obviously you can see there is fault there, but the surface is not faulted. This is quite common when you import this from a surface mapping application, right? So you can see here you have a fault here, right? But then you want to clean the area of your horizons near the fault area, so you can have a better input for your 3D modeling process later, or just for a visualization purpose. You can do that very easily. So what I recommend you to do is convert the data, the horizon data, into a point dataset, because point dataset have more flexibility in terms of editing. And then of course you can have the option to clean the area within the faults. So in this case, I already converted my horizons into point data, and then you can see it's clean inside the fault area here, right? This will be very helpful because you have more control if you want to use this as an input for your 3D grid later. But for in this case, I don't want to go yet to the 3D model process, but I want to have a better display of my map that are faulted, my surface that are faulted. So what I can do is I can create a new surface, right, in using the data points as an input and using the fault as an input as well. So just by two process, creating the new horizons and then cleaning the area around the faults, and then in an instant I will have my new horizon that is already faulted based from the faults, but I haven't even go to the 3D static model building yet. So this is pure just 2D surfaces. So it's still running because I'm doing a very detailed resolution here, but within few seconds later you will see the result. So this is the input data point. Okay, now I have the horizons. You can see here the horizons is still the faulted area is still filled with data. Then let's display also in a map view. But what I can do next is just to clean the area around the fault, and then it will have a proper kind of faulted horizons. So I just need to detect the faults, and this distance here you have to play around with it to see the optimum distance that you want to use, right? The bigger the size of the faults, maybe you want to have a larger distance, right? So, and then I can have the result here, and you can see the new horizon looks like this. And then if you display it in a map, it looks much better in terms of map display. And this one, you don't even have to go to your 3D model yet. The other benefits of having data points as input is you have so much flexibility in terms of editing. Let's say I want to do like a random edit here. I want to just delete certain area. What you can do is you can just draw on the point data there, And this is even, you can do it even in a 3D display, and then just delete the area, and then you can regrid it, right? If you're not satisfied with those results. This one as well. This one, you can just delete it, or you can maybe set a certain depth, certain constant depth. Let's say I'm type 3000 there, and then you can see all the depth where I selected the boundary will be shifted upwards. So that's just show you how easy it is to edit data if it's already converted in as data points. And let's say you have a new fault interpretation coming in, or let's say you don't have a fault interpretation, but you know there's, based from your production data, there should be some barrier between this area and here. But instead of doing a fault from scratch, you can easily just create a blank space here that acts like your fault, right? And then clean the area here, and then use this as an input for your 3D model purpose later. Okay, so that's, we are talking about structural map. Now let's see how T Navigator can create 2D attributes map. Right. In this particular exercise, I will show you how simple it is to create attributes map based on your well log data and your markers. Right. So in this case, I already have markers on a certain depth. Let's say this is top 1. I have the depth structure also. And to create attribute, well attributes here, well top attributes, it's just simply by going to the calculation, and you can see here, you can use the average log between markers. You can select the zone. You can choose whether the log is continuous or discrete. If it's discrete, you can then select whether it's a thickness or a fraction kind of averaging, right? And in this particular example, I already have prepared about 2 examples where I create a thickness of my zone and the thickness of my reservoir, my sand, right? And then you can simply map it, right? Just by going to the interpolation by well attributes, make sure you select the correct attribute, well marker attribute that you just created, right? And then just select which interpolation method that you want to create or want to use. In this case, I'm just using a least square method, the most smoothed one. And I have my zonation thickness distribution. So you can see it's more thick on this side, right? And then if I compare with my, let's say my sand thickness, my reservoir thickness, it also have a little bit of better area here in this area. And let me create another one, which is for my porosity map. Let's say I want to create a distribution of my average porosity. That one also doable. So make sure you choose a continuous log as your input, and then make sure the averaging method is arithmetic, right? And then you just select the appropriate input. In this case, I want to use my average porosity as my attributes, and then I create my average porosity map, right? And these are all done without even, have to create a 3D model yet. So you can have a quick understanding of how your porosity distribution should look like, right? So let me just run it very quickly. And as you can see later on, the result kind of consistent with my reservoir thickness and my net sand thickness just now. It's concentrate on this area and in this area. And of course, this one you can display the contour as well. You can use a more detailed kind of incremental if you want to see more detail how it looks like, right? It's all can be done from this map view. Right? And once you have all the maps created, your 2D maps, your structural maps, right? And then it's always good to have this ready for a report, right, or a presentation. And then you can always combine it with your log data. So for instance, I have this kind of my channel distribution. It's based on a fraction or a percentage, right? A probability map. And then you can display your log signature here, and then just filter out the well that you don't want to use, but only focus on the channel belt here. So this is a good way for peer review, for maps or for reports, right? And then you can use that all using T Navigator. Okay, so the next step will be the 3D static model generation. You have already created your depth structural, you already have the 2D attributes map, your sign isochord, your sign isopac, your porosity distribution, or your facies thickness. Of course, T Navigator have a lot of advanced functionality when it comes to 3D modeling, right? We have implemented all the major algorithm inside T Navigator, but what I want to show you right here is just a quick way of how to QC your input versus your model, right? Because that's what we all should do before we even go to the property modeling process. So in this case, I already created a 3D structural model based on my input, but I want to QC it, how far the difference is between my input that I just created, input that I used, and the output that I just created. So in this case, I just call a cross-section window, and then I display my original horizon. If you remember, the one that's supposed to be faulted, but it's not faulted because I imported from other application, right? And then because I already used this and cleaned this with point data, and then used that point data as an input for my 3D grid, you can see the difference between my 3D grid, which resulted from the input that I already cleaned, right? So the blue color here is my original input, and my green color is my 3D grid horizon. So you can see it's under the faults, right? It's very honoring the original input, but around the area of the fault, it's properly cut and faulted, right? So it's a very advisable way of how to create a 3D grid where you can honor the faults and also have a clean area around the faults area. If you see some difference here, you can always go back and try to edit it later, right? But at least before you even go start with the property modeling distribution, making sure your structural map is honoring your input data. Okay, so let's say you already have, or you already built your model, your facies model, your porosity models, right? Let's just have a very quick look on how you display that. So again, this is my porosity model that I already distributed. I displayed in my cross section, right? The beauty in TNav is that all the windows are very interactive, and the way you set the scale, vertical or lateral, is very interactive. What you need to do is just set the cursor where it is, and it will update the scale. And in this case, I want to show you a 2D map where you display, typically a 3D model where you display, you always only have the ability to display it on a certain layer, right? I, J, or K. And if you want to create a property map, you have to create a separate property map object. But in T Navigator, you don't have to do that. The 2D map window have the ability to either show it the property as a single layer, or a sum, or an average, or a maximum value, or the minimum value of any properties on any certain zone. So you can combine several filters, several zones, and then using this option to display a property map without even have to create a new object like you normally do in other applications. All right, so that demo is the last part of the demo of the software. But let me make a quick summary of what I have shown you today. That, again, we all know as a geoscience, 2D mapping is an essential part of any G&G workflow. And I hope by showing this, other domain can also understand the importance of it, right? So even before you go populate all your 3D model and everything, make sure your 2D maps are properly generated, right? And of course, it will give you better understanding of the structural geometry. You can see the difference if you display it in 3D comparing in 2D map. You can have a better understanding if you display it in 2D map, and of course, better if you combine. Also, user have more control of the data input, right? If you convert it into point data, and then you can clean certain areas and everything, then regrid it again. You have more control, and you can have a better result, which at the end gives you a higher confidence, and hopefully it will reduce uncertainty and gives you better decision, right, to go forward. And I also want to emphasize here that 2D mapping is just part of the Geology Designer, which is the static modeling modules in T Navigator. You don't have to acquire any additional licenses. It's not separated. It's not separate even with the seismic. It's all parked under the Geology Designer. And since it's integrated in a single environment in T Navigator, our engineering friends can also use that map and display it together with, for instance, their production bubble map and charts, right? So it's a very convenient way to work together in a single environment. Okay, so now I think we can go for the question and answer session.
Yeah, thank you very much, Ari, for the presentation, and thank you to the audience for your attention. I think Ari will maybe just do a couple of questions because we're running out of time. We don't want to take up much more of people's day. So do you have a couple of questions there that you want to answer?
Yes, they have here.
Just while Ari's looking at the questions. Oh, our next webinar will take place on Thursday. Have you got a question? Go for it.
Yeah. So let's go for the, okay, this one, the first question: how do you handle very thin deterministic bed from isocores? Do the bed thickness translate across into 3D okay, especially near the faults where interpolation exists? Right, so in T Navigator now we have, in the 3D modeling, you have the control to set the minimum thickness, right, minimum thickness of layering. But of course, if you have thin deterministic beds from isocore, then you really have to make sure that is properly captured in your 3D modeling building. So yeah, we can do that, but of course you have to pay very close attention. And the next one, let's go for the next question. What about interpolation with secondary data sets capabilities? Yes, so that one you can do in T Navigator in the mapping. So you can combine, for instance, your data points, and then use probably a polygon, right, for control of maybe for your oil water context, so the interpolation doesn't go beyond that. So you can do that. Yes, you can do a multiple input or a secondary input for your 2D map creation. Okay.
Cool. Okay, I think we should
be okay. Yeah.
Let's wrap it up there. I can see we've got quite a lot of questions that were coming in, so Ari and I will sort through those, and then we'll make sure that your question's answered if we didn't answer it just there. So thank you very much, everyone, for joining, and thank you very much to Ari, and we look forward to seeing you at our next webinar. Enjoy the rest of your day.